Okay, so now we're in record, and we're going to do a walkthrough of the electronics lab with two potential students. Right now we're in the freshman lab where we do freshman type things, and the first thing we see is a video camera of some sort. Wonder what that is. Well, that's a $5,000 video camera that we use electronic stuff on. It can see flaws down to 0.1 millimeter.
Is it a color camera, or what type of
color? Black and white?
Well, it's color, and we normally use it to count quarters and pennies and nickels because that's easy to do.
Lovely.
And then we see that we have test equipment on our workbench, which is going to be used to do some of your labs. We also have a computer there where we do computer simulations of things. We move around and we get on this side and we see drawers.
Holy cow, that's a lot of stuff. With
parts. So clearly this is a class where we have to do things with parts.
A lot of hands-on.
Yeah, so we have plenty of parts to do things with, and but these are the parts that are required for your freshman labs, the small parts.
Small parts.
Yeah, and when you get done with your parts, you organize them in a very wonderful way so that they're all organized, ready to go.
100% organized.
Yes. We also have projects from time to time, so this is a TV that's not working, given to us by the IT department, and the notice says that it works halfway down, and then there's a line, and the bottom half doesn't show up. Okay, well maybe we can fix that, maybe we can't. We have a three-phase wiring lab where we hook up three-phase power.
Big boy stuff.
To a 1-horsepower motor. Right now it looks like these guys are hooking up a PowerFlex 40, which is a variable speed controller, to make this thing go forward and backwards.
Would this be like what's in a factory or simulator?
Yes, this is control power. I have a control power transformer up there on top, and that's what you'd expect inside your control cabinets, inside your factory. So this is
pretty realistic stuff. What
the freshmen do. They learn which way to turn a screwdriver. When we come over to the sophomore lab, second year students, well, they're into networking program logic controllers together. So we see two program logic controllers networked together using a DH45 network.
That sounds very complicated.
We see around the room, we see a big cable at about 7 feet up, and that is a DeviceNet cable where we learn how to do things in DeviceNet, which is something that is done in industrial base 2. This is the program we use, programming station we use to do our networking in ControlNet and Ethernet.
Nice.
And big screen TV so we can see what everybody's doing, so I can watch the student while they're doing whatever it is they're doing.
Nice.
We have 4 MicroLogic 830s that are new to the program that we're learning how to program using Connected Component Workbench, and it doesn't look like any of them are programmed to do anything right now, but we have 3 of them mounted in this room, and the 4th is being used in the other room someplace. So that's
now are those touch screens down there?
Yes, those are touch screen control.
That's
human machine interface things, and that's something you're going to have to learn how to program.
That's pretty neat.
What would that device do? Control?
It would control part of the assembly line. Not the whole assembly line, but it would control a machine connected to the assembly line.
Interesting. We
come into another room where we also have 3-phase power wiring going on. In this lab we have on the order of $250,000 worth of gear. So there's my first
That robot
robotic
looks
arm.
awesome.
It only moves a mere 2 meters per second in automatic. So when he moves, he shakes the table and swishes the air, and you know that he has moved. There's no doubt about it. We don't program him at that speed. We program him at 1/8 of that speed. And when he's running at that speed, we stand away from him. We also have another robotic arm inside its safety container, which is nice. And we use it to move things around. So I have things in there that gets moved around.
Interesting.
And it would appear that there's some programming gibberish there written on the side too as well. I'm sure that someone will have to figure out what that is sometime. This guy's self-contained. He has his own pneumatic system so that we have air going into him. The big robotic arm, the pneumatic system is in the overhead above one of the math labs. And we, of course, let the air flow just to make noise there.
What does the pneumatics do on it?
Well, it will open and shut the robotic arm. So the electronic part of the system moves the arm, the pneumatics grabs whatever it is that I'm grabbing.
That's
Allows
like
it to
the
close a lot
clamping
faster
thing.
than a motor or something.
So that's pretty cool. This is one of our 2 control net, device net, Ethernet stations that are programmed through the touchscreen monitors to the rest of the room. A lot of parts that are point I/O parts that allows you to have your switches and your indicators remotely away from your PLCs and network together someplace else.
That's pretty cool.
Plenty of wire to do wiring stuff with. Plenty of used wire to do wiring stuff with. And then industrial grade switches and proximity switches and timers and delay things as well. Now this room's also used with the circuit, the sustainable energy people come in here and they program these PLCs as well. This is a SLC 500.
Sustainable energy, that's like wind turbines and stuff, right?
Yes, it is.
Lovely.
Yeah, so we have a wind energy program associated with the program. They use our lab equipment as well. Okay. Are we ready for the math test?
No, what?
Because clearly the program has to do with math. So we'll erase the math that's already on the board, and we'll proceed to test whether or not your math skills are at a level necessary for the electronics program. Okay, so the first question is, what is 1 plus 1?
We're going to guess
Okay.
on that one. Final answer.
1 plus 1. And, okay, so the correct answer is 10. And the guess was 2. So the potential
We didn't take into
students
consideration the base.
have 1 wrong. Okay, so we have 1 wrong already.
Well, looks like we're not
And,
going to be engineering students.
And now we'll go and ask the second question. What is 2 plus 2? 2 plus 2.
This is a trick question.
We're going to guess 4 on that one.
4. Okay, 2 plus 2 is 11, so that's 2 wrong. Okay, now I noticed that you brought your mother with you, and we're going to have her answer the question, what is 3 plus 3, Mom? Okay, so 3 plus 3 is what?
I would say that's about 6.
No, you wouldn't. You'd say it was 12. Because moms always say that 3 plus 3 is 12, knowing that 1 plus 1 is 10 and 2 plus 2 is 11. Okay, so 3 plus 3 is 12. All right, now knowing that, what is 4 plus 4?
I'm going to say 13.
13 is correct.
All right.
Ooh, look at
So
that.
13 is
You're
correct.
already instructing us. We're not even
5
students here.
5 plus
We're not
5.
students.
5 plus 5, what is that going to be?
14.
14. 14 is correct. 6 plus 6.
Let's just say
is,
15.
15.
Then
15.
I think the math portion is
7 plus 7 is What's 7 plus 7?
16.
16. Did either of you bother to bring a calculator with you?
Unfortunately,
If
no.
you-
But I'm
if
sure
you-
all the engineering students have at least 3 of them.
Might be able to
Yes.
find one.
If you had a calculator with you, you could put 7 plus 7 in it and get 16. I did not bring mine in today, so I don't have that option. Okay, so now we're up to 8 plus 8. And what do we want 8 plus 8 to be?
17.
17.
17,
We're going
okay.
with the flow here.
We don't want 10.
And 9 plus 9, this could be difficult. What do you think? 9 plus 9.
Let's go ahead and say, wait, 18.
18. 18. And 10 plus 10?
Let's say 19.
19. 19. 19. Okay, and 11 plus 11. Now, before you answer this particular question,
Oh boy.
the instructor, you notice
I
that
think
is
I'm
grabbing
ready. I
their
think I got
red
this
pen. Okay, so I'm ready. What
All
is
right.
11 plus 11?
Would it be 11?
All right. No. Do we have a second answer?
20.
20. Okay, so no, not 20. When I get to 20, it doesn't work.
Oh.
Oh.
All right, now there's an English component part of this test. Okay, the English component part of the test is what literary character, okay, that makes 3 wrong, by the way. What literary character says that 1 plus 1 is 10, 2 plus 2 is 11, 3 plus 3 is 12. But when I get to 20, it doesn't work. Who said that?
Well,
You did.
I'm
not sure.
I'm not very up to date on my latest English figures here.
I see. Well, was it in the Lord of the Rings? Did anybody say that in the Lord of the Rings?
I don't think so.
No. How about the Chronicles of Narnia? Anybody say it in the Chronicles of Narnia?
I don't think so.
Okay, so that only leaves one other place it could be, and that's Alice in Wonderland. So the Jabberwocky in Alice in Wonderland, that's what he says when he's talking. Now, why is it that this is so important to the electronics people?
That's actually the hardest question asked here so far.
All right, so this is base 2. Base 2 is binary.
Aha.
Binary is something that we like
I knew it had
because
something to do with binary, and
binary
bases.
is off and on. So when we come over and we take the light switch and we go off and on, that's a binary situation. Off and on.
A 1 and a 0.
1 and a
Wow.
0, yes. And then this is base 3, so 3 plus 1 is 4, base 4, 5, 6, base 7, base 8, which is also octal. So octal is important to us because we didn't want to put a bunch of 1s and 0s into our computer one time, and we decided that we should enter an octal code. 9, 10, that's base 10, 11. But 20 in base 12 would mean 2 12s. 2 12s is 24, and that's why it doesn't work.
That's interesting.
Yes. The electronics lab has many other things that are
So
cool.
I'm guessing base 10 is what we're used to. Everyone
Yeah,
is
yeah.
used to working it.
Base 10 is what you do all the time. Okay, any other questions?
I think we're great. Oh yeah, I have a question. How
Excellent.
much did one of those robots cost back there?
Well, the bigger one was a mere $40,000,
Holy cow!
and the little one was $45,000. And
What? The little one costs more. What's up with that?
Well, that's because when we bought the big one, it was excess at the manufacturer, and he had no place to put it. So if we were going to pay for it for real, it would have been more like $200,000.
Oh my gosh! Those things are
But somebody else wanted the tax deduction, and so we ended up with the robot at the $40,000 that we could afford to pay for it.
bargain.
All right, any other questions? Okay, so
I think we're all good.
Electronics students, graduates are fully employed. There's no such thing as an unemployed graduate. We have many different toys that we play with and we have to be able to do. We have 7 different computer programs we have to learn how to make work. And we have a lot of fun every single day.
Sounds really good. Thanks for that tour.
Oh, you're very welcome.